Hi, I'm Avery.
And I'm Heidi.
And we have some news.
We are on house arrest.
People think we are crazy because of our mathematical theories.
We believe that you can measure objects without directly measuring them, because you can figure out the height of any object by calculating other measurements.
There are 3 different ways to do this. There are string method, shadow method, and mirror method. We are going to prove our theory through mirror method.
To do mirror method, you need a mirror, a second person, and a measuring tool, preferably in centimeters, and of course an object to measure. For our example, we will be using a climbing wall.
First, place a mirror on the floor a little bit away from the object you are measuring. Next, you stand directly behind the mirror and then back up until you can see the top of the object in the mirror. Finally, you measure the distance between the mirror and the object, you and the mirror, and your eye level to the ground.
Then you can calculate the height of the object using proportions, since the triangles formed are similar.
The reason we know that the triangles are similar is because of the properties of reflection. One property states that light is reflected at the same angle that it goes into the mirror. A normal is the line that forms a 90-degree angle with the ground and bisects the angle from reflection. This means that the 2 angles outside of the triangle formed by the normal are congruent. Since those 2 angles are congruent and the angles inside the triangles are complementary, then the angles inside the triangle are also congruent.
Along with this angle measurement, we also know that the angles at points D and B are 90 degrees. Since we know 2 angles, we also know the third. Therefore, the triangles are similar. Because we know they are similar, we can now use proportions to find the unknown height of the climbing wall.
To set up our proportion, we are going to start by renaming the unknown height x. We are going to put x over line AB and make it equal to line DC over line CB.
Then we cross multiply to get 79x equals 20,850. Then you divide both sides by 79, getting x equals 290.5. We know this number is accurate because in our example, we could actually measure the climbing wall. The height of our object is 345.5 centimeters, and the height we got by using our theory is 290.5 centimeters, which is only 81.58 centimeters off.
What we've made in our measurements are the measuring tool itself. We used a meter stick to measure, where a measuring tape probably would have been more accurate than marking the spot with our finger, then moving the meter stick. And since we used a meter stick, it might not have been straight, which could add a few centimeters.
A human error could have been us not standing straight, or we might have moved before taking measurements.
Conclusion, our method of measuring the height of the climbing wall was accurate. Although our calculated height was not exactly the same as the actual height, the possible errors in the process of measurement account for the difference. So, since our method is proven to have been accurate, we should not be on house arrest anymore.
Thank you for your time, and we hope we see you in the future. Hopefully not on house arrest, though.